Now let's look at non-square systems. So far, each system of linear equations you have looked at has been square, which means that the number of equations is equal to the number of variables. So when we did two variables, we had two equations and two variables, and then we've done three equations with three variables. In a non-square system, the number of equations differs from the number of variables. So for example, the example below, we have three variables, but we only have two equations. So that's called a non-square system. A system of linear equations cannot have a unique solution unless there are at least as many equations as there are variables in the system. So this is how you solve a system with fewer equations than variables. We're going to solve the system of linear equations here. It's actually very similar to our infinite solutions, which is why this comes after that. So to solve for this, number one, this is in our first equation is fine. It's in the first position with leading coefficient of 1. So let's multiply -2 to equation 1 and add it to equation 2. So -2x plus 4y minus 2z equals -4. And then we write the second equation, 2x minus y minus z equals 1. So now we get 3y minus 3z equals -3. So let's write our new system here. We have x minus 2y plus z equals 2. Then we get 3y minus 3z equals -3. Now I want to simplify the second equation a little bit. So I'm going to multiply the second equation by a third in order to make it a leading coefficient of 1. So x minus 2y plus z equals 2, and y minus z equals -1. So now we're going to solve for x by back substituting the y, substituting. So we have x minus 2, and actually let's go ahead and we have to solve for this first, right? We can't really do it. So y equals z minus 1, and so we'll put that in there. So this is -2 times z minus 1 plus z equals 2. So let's simplify x, and then minus 2z plus 2 plus z equals 2. So this becomes x minus z plus 2 equals 2. Subtract 2 from both sides. So x minus z equals 0, or x equals z. So now we're going to go ahead and let z equal a. And so since we know x equals z, and z equals a, therefore we know this is a, and this is a. So now we need to solve for y. So let's plug it in. Let's plug in y equals into this one. Y equals a minus 1. So that is our answer. So here is our ordered triple. The solution set includes all ordered pairs in this form where a is a real number. So we could plug in any number here, and then that's where our solution is. So try this example here. Solve this system of linear equations doing the same thing. And it'll be very similar to the last example. All right, tried this out. You would have gotten a fraction. And so you would have gotten this equation here, right? You multiply -4 to equation 1 and added it to equation 2. Then I multiplied it by a 4, so I had the leading coefficient of 1 in the front. So then we solve for y. So y equals 17 over 4 times z minus 3. And then I'm going to let z equals a. So this just kind of helps set it up. You could always let z equals a first and then solve for everything else. That's okay as well. So z equals a, then I know y equals 17 over 4a minus 3. So I know that's what goes here. Then we solve for x. So we plug it into the equation 1. Plug in our y and z in there. And you would get x equals 1/4 a. So the last thing we're going to do is using data analysis and curve fitting. We're going to find a quadratic equation where y equals ax squared plus bx plus c, whose graph passes through these 3 points. So we've done this before, or hopefully we've done this before, maybe in Algebra 2. And so we're going to try to find a curve using solving solving it using a system. So remember, this is the equation here. And so this represents our x and our y. So let's do this. When x equals -1, we know y equals 3. So we can write the equation. So this is the equation we're using. And so we have a, and x is -1 squared, plus b times -1 plus c equals our y, which is 3. So that's our first equation. Then when x equals 1, y equals 1. So a times 1 squared times plus b times 1 plus c equals 1. Then the last one is when x equals 2, y equals 6. So it's a times 2 squared plus b times 2 plus c equals 6. So let's simplify this a little bit. So equation 1 will end up being just a minus b plus c equals 3. Equation 2 is a plus b plus c equals 1. Then the final equation, third equation, is 4a plus 2b plus c equals 6. So now we're going to solve this system. So what we're going to do is we can take equation 1 and subtract it from equation 2. So we have a minus b plus c equals 3. Subtracting equation 2, just change the signs to the opposite sign. So we get negative 2b equals 2. So we're going to write that system. So we have a minus b plus c equals 3. We get negative 2b equals 2. And we have 4a plus 2b plus c equals 6. So now I'm going to multiply negative 4 to equation 1 and add it to equation 3. So just doing the work down here, this is negative 4a plus 4b minus 4c equals negative 12. Add it to equation 3. Oh, that's a b, sorry. 2b plus c equals 6. And so we get 6b minus 3c equals negative 6. So let's go ahead and write that up here just as we're working. So we have a minus b plus c equals 3, negative 2b equals 2, 2b equals 2, and then now we have 6b minus 3c equals negative 6. And so what do we want to do next? Let's see. Let's go ahead and let's get rid of b. So let's multiply the negative 2b over here by 3. And then we're going to add it to equation, so that's equation 2, and we're add it to equation 3. So this is negative 6b equals 6, and then we get 6b minus 3c equals negative 6. So we find that negative 3c equals 0. And then let's go ahead and simplify already. C equals 0 here. So this is a minus b plus c equals 3. We get negative 2b equals 2. Negative 2b equals 2. Let's go ahead and simplify that right now and make that b equals negative 1 and c equals 0. So now we're going to back substitute. We need to solve for a. So a minus a negative 1 plus 0 equals 3. So a plus 1 equals 3. Or we get a equals 2. So now our equation, a is 2, b is negative 1. So we can say y equals 2x squared minus x. And so that is our equation. So just more practice in solving systems. So go ahead and try this last example here. Find a quadratic equation who passes through 0, 0, 3, negative 3, and 6, 0. All right, so if we tried this out, you should have gotten y equals 1/3 x squared minus 2x.